Okay, so this next lesson in our ecology unit is specifically on populations. So it says here a population is all the members of the same species living in the same habitat. So if you guys can recall from our first ecology lesson, it was the intro to ecology lesson. We learned that an ecosystem begins with a single organism, and then a group of organisms of the same species make up a population, and then different populations of different species make up a community, and then the interaction between like all the living things, like the biotic factors, and all the non-living things, the abiotic factors, make up an ecosystem. So today we're going to specifically talk about the populations component of the ecosystem. So again, the group of organisms of the same species that makes up a population. So all the members of the same species living in the same habitat. So we have an example here. So all the fish in a pond. Another example would be, say, all of the deer in a forest ecosystem. So all of the organisms of the same species in the habitat. Okay, so all the deer, all the fish, all the wolves, all the frogs, those groups of specific species make up a population. Quickly highlight that population. Okay, so this next slide focuses on the carrying capacity. So the carrying capacity is the maximum number of individuals of a species that can be supported by an ecosystem. So there's always a maximum amount of individuals of a specific species that the ecosystem can sustain or support, or like the maximum amount of individuals of a species that can survive within a specific ecosystem. This amount is determined by the availability of resources such as food, water, habitat, and beyond that. So even more specifically, like this amount is determined by different factors like resource availability, including water access or water amount, food, so if there is, say, enough producers for an animal that's a herbivore, or say if there's enough prey for a secondary consumer, whether or not there is a habitat, so like access to a safe shelter. All of these different resources contribute to the carrying capacity or the maximum amount of individuals of a species that can be supported in an ecosystem. So you'll notice down here in this graph, okay, in this graph we're looking at time versus population number of a specific species. And you'll notice that as time goes on, we have a population that increases and it exceeds the carrying capacity. So this blue line here, guys, is the carrying capacity. So that would be the max number of individuals of a species that can be supported by the ecosystem. So you'll see that the population increases, it exceeds, and then it decreases, it goes below, and we have this pattern where it increases, decreases, and then eventually the population levels out to meet up with or reach the carrying capacity. And there are different reasons as to why this population would exceed and then go below the carrying capacity. And we're going to talk about it on the next slide, which is limiting factors that can kind of cause that to happen. But remembering, the carrying capacity is like the maximum number of individuals that can thrive and survive and for it to be sustainable for those organisms in that ecosystem. Have carrying capacity, very important. Okay, next, like I was saying on the last slide, there's something called a limiting factor, and this is any resource that limits the size to which a population can grow. So there are different factors that prevent a population from reaching something called its biotic potential, or its maximum number of individuals. And it's something that really restricts a population size. So I have examples here, food and shelter. So if there's not enough food or if there's not enough food, then that could be something that limits a population from being able to grow. Shelter, if there's not safe protection or safe habitat for the organism to live in, then that could be something that limits the population. Okay, so there can be both abiotic and biotic factors that limit a population. So some more examples, abiotic could be like lack of sun. Okay, so maybe not enough heat energy. Another one could be pollution. Okay, pollution could be an abiotic factor that limits a population from being able to grow. And then there could be biotic living factors. So things like predators could limit a population from growing. Disease can limit a population from growing. So this graph here, I'm going to go over it with you. This is an example of a limiting factor having an effect on the population of a specific species. So you'll see here we have a whole bunch of fish. So here we have a population of fish. So what is that? A group of fish of the same species in an ecosystem. And on the y-axis here, we have population size, so from low to high, so it's increasing. And then down here, we have the abiotic factor that's going to affect this population size. So this down here represents the limiting factor that's going to kind of increase or decrease the population size. So down here, I'm going to say, let's pretend that the abiotic factor that we're going to look at here is, say, temperature of the water. So the effect that the temperature of the water has on the population size of, say, a specific species of fish. So if you look down here, when the temperature is low, okay, there's no population of fish. That means that this temperature of water, okay, is outside of the fish's tolerance range. So you'll see up here from this yellow block to this yellow block is considered this species' tolerance range. It can survive. In the tolerance range, it's not so much thriving, but it can still survive in that range. So you'll notice that over here, if the temperature is too low, so we're too low, there's no fish, there's no population. If the temperature increases a little bit, and then we get to this block here, you'll notice the population starts to increase a little bit, but it's still low, but now we're in the tolerance range. So that's why we're able to have some sort of population. As the temperature gets a little bit warmer, you'll realize that now we're in the optimum range. And the optimum range is like that range that this species can thrive in. So here you see a very high population because at this specific temperature in this area from here to here, we're in the fish's optimum range. Okay, so a high population is going to exist if the conditions are optimal for the species survival. As you continue, and now we're getting a little bit into a higher temperature, you'll notice that we're coming back down because now we're leaving its optimum range again and we're entering the tolerance range. So this is now a temperature that, again, they can somewhat survive in, but it's not optimal. So now we're back down to a low population. And then this highest temperature here, we again see no population because that's now outside of the fish's tolerance range. Okay. So that's an example of a limiting factor having an effect on population size. Okay, so here we have factors that cause a population to increase, both abiotic, non-living, and biotic living, and then factors that cause a population to decrease, both abiotic, non-living, and biotic living. So factors that cause a population to increase that are non-living, favorable light, okay, good amount of light from the sun, good temperature. Biotic, good amount of food, low number of predators, few diseases or weak diseases, being able to compete for resources. These are all factors that are going to allow a population to increase or reach its biotic potential. Factors that are going to cause a population to decrease include not enough light or too much light, too little warmth or too much warmth from the sun. And here says unfavorable chemical environment. So chemical meaning like maybe the salinity of the water, so the salt concentration of the water. Insufficient food, so not enough food, too many predators, too many strong diseases, not being able to compete for resources. Okay, so these are factors that would cause a population to decrease. So we have increase, abiotic and biotic, decrease. Okay, that was the lesson on populations. You guys have a practice page in your booklet, and you also have the graphing assignment that you can work on.